In today's lesson, we'll be learning how to transform a quadratic relation. This is the equation of a quadratic relation. Its a value is positive 2. Because this is positive, that means the parabola is smiling or opening upwards. It also means that there is a vertical stretch by a factor of 2. How do we know it's a stretch? Well, if the a value is greater than 1, that means it's a stretch. And if it's between 0 and 1, that means it's a compression. As you can see over here, there are no other numbers to analyze. And that is because our original h value must have been 0, because if you subtract 0, you don't really need to write that in. And our original k value must have been 0 as well, because if you add 0, you don't need to really write that in as well. So our h and k values were both 0, which means it is neither horizontally translated left or right, and it is neither vertically translated up or down. If you recall, this is the parent function of a quadratic relation. Y equals x squared represents a parabola in its simplest form before any transformations have occurred. Based on the information we gathered before, our newly transformed parabola is going to be opening upwards, and it's going to have a vertical stretch by a factor of 2. I want you to take a close look at the images of Mr. Fantastic in the background. We're going to vertically stretch him by a factor of 2. The image of Mr. Fantastic on the left has a height of 4 units. His new height is going to be 8 units. The shorter Mr. Fantastic on the left has a height of 1 unit. His new height is now going to be 2 units. The vertex is going to stay in the exact same spot, and I'm going to double the heights of the other Mr. Fantastics on the right. As you can see, our newly transformed parabola is opening upwards, and it has been vertically stretched by a factor of 2, which means it now is more narrow. In our second example, we have an equation of a quadratic relation. Its a value happens to be 0.5 or 1/2. Because this is positive 0.5, that means our parabola is going to be smiling or opening upwards. And because our a value is 0.5, that means there's going to be a vertical compression, because 0.5 is located between 0 and 1, whereas a value greater than 1 would be a stretch. I want you to take a close look over here. You'll notice that there are no other numbers to analyze, and that is because the original h value was 0, and if you subtract 0, you don't really write that in, and our original k value was also 0, because if you add 0, you don't really need to write that in as well, which means our h value was originally 0, so our parabola is neither horizontally translated to the left or to the right, and our original k value was 0, which means our parabola is neither vertically translated up or down. The image down below shows the parent function of a quadratic relation, or y equals x squared. Our newly transformed parabola will be opening upwards, and it will have a vertical compression by a factor of 0.5. Take a look at the image of Mr. Fantastic in the background. We're vertically compressing him by a factor of 0.5, which means he's going to get shorter. The Mr. Fantastic on the far left originally has a height of 4 units. He is now going to have a height of 2 units. The shorter Mr. Fantastic on the left has a height of 1 unit. His new height is going to be half of that. So 0.5 units or half a unit. The vertex is going to stay exactly the same. I'm going to shorten the other Mr. Fantastics on the right. As you can see, our newly transformed parabola is opening upwards, and it has been vertically compressed by a factor of 0.5. You'll notice that the new parabola now appears wider than before.